Welcome to the Deep Dive. Today, we are strapping in for what might be the biggest industrial pivot since, I don't know, the Model T rolled off the assembly line.
It really feels that big, doesn't it?
It does. We're moving from horsepower to electrons, and the stakes for global manufacturing, national security, and frankly, your wallet couldn't be higher.
Yeah.
We've been handed a stack of sources that paint a pretty dramatic picture. The world is currently sort of awash in ultra-affordable electric vehicles. We're talking like $10,000 EVs.
Unthinkable numbers here.
Exactly. But the U.S. market, it's guarded by this massive, literally triple-digit tariff wall, keeping those cars strictly out.
It is a profound moment of tension. You provided us with sources that lay out, the current slowing status of the U.S. EV market.
Right.
The astonishing state-backed cost lead held by Chinese manufacturing, especially BYD.
BYD keeps coming up.
They're central to this. And then there's the stark economic cost of protectionism and the strategic choices facing Washington and Detroit right now.
So our mission today isn't to, pick a winner in this trade war.
No, absolutely not. Our goal is to meticulously unpack the unavoidable trade-offs here. We need to understand the balance policymakers are trying to strike.
Between what?
Between consumer welfare, meaning, cheaper cars for you, the listener.
Which everyone wants.
Of course. Then there are urgent climate goals, and also this desperate need to secure the next generation of American industrial capability. It's a tough balancing act.
Okay, let's unpack this dilemma then. The central tension here, and the analysis really stresses this again and again, it's fundamentally about cost and geography.
Cost and where things are made, right?
Right. The U.S. has to decide. Will it simply import BYD-level prices? Hand over the industry maybe, but benefit consumers immediately.
That's one path, a potentially painful one for industry.
Or does it have the will and, frankly, the capacity to domesticate those BYD-level costs? I mean, can we actually make them here at that price point?
That's the billion, maybe trillion-dollar question.
Or, and this is the really radical pivot, does the U.S. fundamentally change what it even focuses on winning in the mobility space altogether?
And that decision point, that's what's driving this entire global competition. The urgency, as you said, it's driven by a price shock.
A shock is right. Which brings us straight to the core issue. This massive affordability gap separating, us in the North American market from pretty much everyone else.
It's huge.
Let's start with a necessary reality check on the U.S. market itself. We've seen growth, absolutely.
We have. The sources indicate that the U.S. electric car share reached about 10% in 2024.
Okay, 10%. What does that translate to in actual cars?
Roughly 1.6 million units sold last year, which, is solid growth compared to 5 years ago.
But sense a but coming.
There's definitely a but. Here's where it gets really interesting. That growth. It slowed sharply in 2024.
Slowed down. How sharply?
Quite a bit. And analysts are actually anticipating that it will stall entirely or maybe even dip in late 2025.
Slaw. Wow. Is that because people just stopped wanting EVs?
Not really a change of heart, no. It's more of a direct policy shockwave hitting affordability.
The tax credit.
Exactly. Crucially, that $7,500 federal tax credit, it expired on September 30th, 2025.
Gone. Just like that.
Gone. And that expiration immediately pushed up the effective price for the average buyer. It wasn't theoretical. We saw real-world consequences instantly.
Like what?
Well, companies like Tesla, for instance, raised their lease rates right after October 1st because they lost that underlying subsidy cushion.
So the sticker price or the monthly payment just jumped.
Effectively, yes. And analysts are predicting the market will probably dip from that 10% to 12% peak we saw in the rush before the credits vanished. Demand is just hypersensitive to price at this stage.
Okay, so the U.S. market cools off potentially significantly right as the rest of the world is starting to see mass affordability.
That's the painful contrast.
Which brings us to the core data point you mentioned, this unthinkable affordability gap. Let's see the numbers.
It is genuinely brutal when you lay them out numerically. Look at BYD's lineup in China, their little Seagull city car.
The Seagull, right.
It's advertised for roughly 56,800 to 69,800 yuan.
Okay, yuan. What's that in dollars?
When you run the conversion, that is approximately 7,800 to 9,500 US dollars.
Wait, under 10 grand for a real car.
For a fully functional, modern electric vehicle built by arguably the world's most vertically integrated auto company, less than $10,000.
That's staggering. And it's not just tiny city cars, right?
No, that cost curve extends up their lineup. Their Dolphin hatchback, which is a car comparable in size to, say, some compacts here in the U.S.
Like a Chevy Bolt size, maybe?
Roughly, yeah. That's priced around $13,700 to $17,300 over there.
Okay, 13 to 17,000. Now contrast that with the cheapest mass market EV currently available here in North America. What are we looking at?
Well, the cheapest comparable mass market EV, let's take Tesla's refreshed China-built Model 3 rear-wheel drive that still runs you around $33,000 to $36,000.
33,000 minimum. And that's probably before any options or, dealer markups.
Exactly. And many of the announced affordable U.S. entries, the ones Detroit is working on, they're still aiming for maybe a $30,000 baseline before you factor in financing costs or anything else. And that's without the federal credit helping out anymore.
So their cheapest car is half, maybe even less than half, the price of our cheapest comparable car. Maybe closer to a third in some cases.
The gap is enormous. If their products are 50 to 75% cheaper, you see the chasm.
So if the U.S. can't match that cost curve domestically yet, the immediate and, let's be honest, politically unavoidable response has been this massive firewall.
Absolutely. And we really need to dive into the kind of technical details of this tariff wall because it's way more than just a typical 25% import duty you might see elsewhere.
Okay, so what are the exact rates and what parts are they really targeting?
The key number, the one everyone talks about, is the tariff on the finished vehicle itself. U.S. tariffs on Chinese EVs are currently set at 100%.
100%. So double the price just from the tariff.
At least. And that's layered on top of some older duties, too, making the effective rate just completely prohibitive. But it's not just the finished car.
Right, you mentioned components.
Yeah, strategically, the U.S. has added additional 25% duties on many essential EV components, specifically hitting lithium-ion batteries and key battery parts.
So even trying to import the battery pack is penalized.
Heavily. The whole structure is designed to make importing any BYD vehicle or even its major guts like the battery commercially just non-viable. Completely shut the door.
What's fascinating here, and the sources really stress this, is the legal and political sustainability of this. This isn't just some temporary measure, is it? It feels built to last.
That's a critical insight, yeah. This regime is maintained under what's called Section 301 actions of the Trade Act of 1974.
Section 301. Remind us, what does that actually allow?
Essentially, Section 301 lets the U.S. government take unilateral action, meaning act on its own, against foreign trade practices it deems unfair or discriminatory. Things like IP theft, forced tech transfer, that kind of thing.
Without needing immediate WTO approval.
Correct. It kind of bypasses the standard, slower international trade dispute process. And while these actions are subject to review, usually every 4 years, they can legally be renewed and maintained for years.
So wait, if the U.S. is slapping a 100% tariff on something, why isn't this immediately challenged and struck down by, the World Trade Organization?
Well, because the U.S. framed this specifically as a response to these long-standing unfair trade practices. Using the Section 301 mechanism gives it a different legal standing than just a purely protectionist tariff.
Huh. It's about the reason given.
Exactly. And politically, it's very difficult for global trade bodies to effectively challenge it, especially when the domestic consensus in the U.S. across both political parties really is strongly supportive of defending domestic industry against what's seen as unfair Chinese competition.
So politically, it's solid ground for now.
Given the current environment, highly skeptical of Beijing's industrial practices on both sides of the aisle. Yes, this structure looks politically and legally sustainable for the medium to long term.
Okay. And BYD, they're not stupid. They saw this wall going up, and they had a pretty smart strategy, didn't they? Trying to use the back door through Mexico.
That was the logical next move, yeah. Exploit the USMCA, the North American Free Trade Agreement.
The new NAFTA.
Right. The thinking was if you can build, say, 60–70% of the car's value in Mexico, maybe you could slip under that tariff fence with much lower duties.
Makes sense. Did it work?
Well, the U.S. policy apparatus moved pretty quickly to close that potential loophole. There was significant U.S. pressure on Mexico.
And Mexico itself had concerns.
Yes, combined with Mexico's own proposed plan for tariffs of up to 50% on Chinese autos, which was partly Mexico protecting its own domestic suppliers from a flood of cheap Chinese parts. It strongly deterred BYD's investment.
So Mexico put up its own wall, essentially.
In a way, yeah. Sources confirm that BYD paused or even canceled large-scale factory plans in Mexico. They seem to be redirecting those expansion efforts now to places like Brazil and Thailand, where the trade barriers aren't as high.
Okay, so the firewall is holding north and south. The tariff regime is stable. But the cost, as you mentioned earlier, is clear. It's a trade-off. We're sacrificing consumer welfare and maybe the speed of decarbonization.
For industrial policy and securing our supply chains, that's the choice being made.
So what does that sacrifice actually look like in dollars and cents for the average American car buyer if that wall came down?
It's stark. If those 100% gates were just open today. And okay, even if you factor in some basic shipping and import costs, maybe some homologation,
Sure.
those BYD class cars like the Dolphin or Seagull, they would immediately pull the EV price floor down by anywhere from $8,000 to $15,000 compared to the typical U.S. MSRPs we see now.
$8,000 to $15,000 cheaper overnight.
Potentially, yeah. That is a massive expansion of what economists call consumer surplus. It would significantly broaden access to EVs for lower and middle-income buyers who are completely priced out right now.
And that would speed up fleet turnover, getting older gas cars off the road faster.
Much faster. Basic Econ 101. Cheaper imports mean higher consumer surplus and faster adoption. In essence, the U.S. consumer is currently footing the bill for this industrial protectionism.
And this cost burden feels particularly, frustrating when you look at how quickly China achieved this price advantage. It feels like just yesterday they were seen as automotive laggards.
It's the great industrial irony of our time, isn't it? For decades, China's internal combustion engine ICE auto industry was kind of an afterthought globally.
Right, they were building Buicks for VWs under license.
Exactly. Mostly importers, imitators, or license builders for the big Western and Japanese giants. They were focused on just catching up to 20th century technology. But today, firms like BYD, NIO, XPeng, they're the ones setting the pace. They're exporting new battery chemistries, new software paradigms. They effectively managed to skip the huge sunk costs and legacy structures of the ICE era.
So how? How exactly did they rewrite the industrial rulebook so incredibly fast? What was the secret sauce that created that, $8,000 electric car?
It wasn't really one secret ingredient. It was more like a combination of, first, unrelenting long-term strategic vision.
Vision.
Yes, and second, a highly coordinated policy structure. The sources call it the policy flywheel. This wasn't some accident or lucky break.
How far back does this vision go?
China declared new energy vehicles, or NEVs, a strategic national priority as early as 2001.
2001. That's ages ago in tech terms.
Exactly. This meant a decades-long commitment from the top, not just some short-term political favor or reaction.
And this flywheel, it wasn't just about giving subsidies to people buying the cars, was it? It sounds more complex.
Oh, much more complex. It was a simultaneous, coordinated push across government and industry. Yes, they offered enormous subsidies for both production and adoption, making the cars cheaper to buy and build.
But also creating demand.
Crucially, yes, they imposed mandates on local governments, forcing them to rapidly replace their internal combustion fleets, buses, taxis with electric versions. This created massive, guaranteed early demand for the manufacturers.
So the factories knew they'd have buyers.
Guaranteed buyers. Then they ensured industrial clustering, concentrating supply chains geographically, like in Guangdong or Anhui provinces, for efficiency. They funded R&D heavily. And critically, they ensured rapid grid expansion.
Charging infrastructure.
Millions of charging points rolled out nationwide, far ahead of where the West was. They basically decided, we won't beat Germany on mechanical precision from the 20th century. We'll beat everyone on 21st century batteries, affordability, and integration.
Which brings us squarely to the new heart of the car, the battery. China made a very calculated choice, it seems, to own the core technology.
And that decision fundamentally defines global EV affordability today. They executed that part perfectly.
How dominant are they?
Today, just 3 Chinese firms, CATL, BYD itself, and CAB, those 3 control more than 60% of global lithium-ion battery output. 60%.
Wow. And it wasn't just about volume, was it? It was about the type of battery.
Exactly. While Western companies may be chasing range and performance for early luxury EVs, focused heavily on nickel-heavy batteries, NMC, and CA chemistries.
The ones known for higher energy density.
Right, more range per pound. China, meanwhile, focused intensely on refining LFP lithium iron phosphate chemistry.
LFP? Okay, why LFP? If nickel gives more range, why bet on LFP?
It was a strategic masterstroke, arguably. High nickel batteries do offer better energy density, which appeals to early adopters worried about range anxiety, people buying expensive Teslas or Lucids.
But LFP?
China realized that LFP, while a bit less energy dense per pound, is inherently safer, less prone to thermal runaway.
Fewer fires.
Potentially, yeah. It relies on cheaper, much more abundant iron instead of volatile, expensive nickel and cobalt. And critically, it's dramatically more scalable for mass production.
So perfect for affordable cars.
LFP is exactly what you need for a mass market, urban, or commuter vehicle where maybe 200 miles of range is perfectly fine. China owned the cost equation by dominating LFP production and R&D.
And BYD, with its vertical integration, just took that LFP advantage and ran with it.
Precisely. BYD's supply chain model is, well, almost unique in the auto world today. They produce everything in-house.
Everything.
Pretty much. The lithium processing, the battery cells, the motors, the power electronics, the chips, the seats, the dashboards, the semiconductors.
They even mine their own materials.
They have investments in lithium mining, yes. This incredibly tight control shortens supply chains drastically, it protects their margins, and it lets them accelerate innovation cycles because they control all the pieces.
And that blade battery we hear about.
That exemplifies this. Their blade battery design simplified the structure of the battery pack itself. It uses long, thin LFP cells arranged efficiently. This improved thermal management, safety, and crucially, allowed the battery pack itself to become a structural part of the car's chassis.
Cell to pack or cell to body.
Exactly. Massive efficiency gain. That integration, combined with LFP's cost, is really what enabled that sub-$15,000 entry point for cars like the Dolphin.
So it's not just a hardware manufacturing competition anymore. It's organizational, it's supply chain mastery, and software too.
Absolutely critical. While you could argue Tesla pioneered the idea of the software-defined car.
Over-the-air updates, big screens.
Right. But Chinese firms, en masse, industrialized it at scale. Over-the-air updates for everything, sophisticated in-car AI assistance, deep integration into the broader digital ecosystem like WeChat. That's just standard now on even mid-range Chinese EVs.
And they learn faster.
That's the key feedback loop. Their operating systems are constantly trained on real driving data collected from millions of users across China, constantly updated via fast 5G networks.
So the cars get better every week.
Effectively, yeah. This rapid, often mandatory data feedback loop creates a continuous product improvement cycle that makes their vehicles feel constantly fresh and technologically relevant in a way Western cars often struggle to match. They built a better system for building and improving cars, not just the car itself.
Okay, wow. There's a clear picture of the price gap and how China built that industrial superiority. Now let's pivot back to the American trade-off. We understand the protectionism, the 100% tariff wall. If that wall did fall, we know consumers would win on price. But what about the stability of the rest of the U.S. economy? What's the risk?
The ripple effects, the general equilibrium effects, would likely be highly disruptive. And this is clearly the source of Washington's acute hesitation, the reason for that 100% number.
How disruptive?
The domestic price pressure would be immense, almost overnight. Every U.S. brand Ford, GM, Stellantis, but also the Korean, Japanese, and European brands building cars here in North America.
Hyundai, Toyota, BMW.
All of them. They would face immediate and steep price cuts and significant margin squeezes. They have to slash prices just to compete with BYD's landed cost, even if that cost was slightly higher than in China due to minimal import duties and shipping.
And we're talking about a huge chunk of the U.S. economy that's tied to the auto sector, right? It's not just Detroit.
It's massive. The automotive complex, when you factor everything in, is tied to approximately 3% to 5% of total U.S. GDP.
3 to 5%, that's huge.
It is. Our sources estimate that the total output effects, including all the linked industries, the suppliers, everything, are over $1.2 trillion, with value added exceeding $450 billion.
And with the T.
Yes. And that economic footprint, it's not just the big assembly plants in Michigan or the South. It includes that vast, intricate network of Tier 1, Tier 2, Tier 3 suppliers, making everything from seats to wiring harnesses.
The logistics networks, the trucking.
The local dealerships in every town, and all the dependent sectors like high-strength steel, advanced plastics, aluminum, and now the burgeoning domestic semiconductor industry that's trying to supply auto chips.
So if the U.S. were to kind of lose that auto manufacturing base to imports,
the reverberations across manufacturing employment, specialized capital investment, and regional economies would be, frankly, catastrophic. It's a foundational industry.
that huge economic risk really puts the affordability versus green inequality debate into sharp political focus, doesn't it?
It absolutely does.
If we keep prices high with tariffs to protect that domestic industry, we inevitably slow down EV adoption, which directly impacts climate goals.
Exactly. This is the core moral and economic conflict embedded right inside that tariff policy. Slower EV adoption, because the cars are too expensive, means slower progress toward reducing transportation emissions. It's unavoidable.
And it creates this weird situation.
Yeah, if the average EV price is hovering around, say, $47,000, as it did recently even with some credits, the green transition becomes a luxury good, a privilege of the affluent.
While everyone else keeps driving older gas cars.
Right. This widens that eco-inequality gap. Lower and middle-income households keep driving older, higher-emission vehicles for longer, while their slightly higher prices on all goods, due to protectionism, indirectly subsidize the purchase of cleaner vehicles by wealthier households. It's a tough dynamic.
But the core argument for keeping the tariffs, for the protectionism, is that the U.S. industry just needs this critical window of time, right? It needs breathing room to actually realize the benefits of the hundreds of billions of dollars it is already committed to EVs and batteries.
That's the crucial nuance the policy is built on. You have to understand the tariff wall isn't really meant to protect yesterday's gasoline engine factories indefinitely.
It's about the future.
It's designed explicitly to protect the future battery and electric vehicle industry that the U.S. is actively trying to build right now. Since 2021, spurred by legislation like the IRA and bipartisan infrastructure law, the U.S. has catalyzed commitments totaling hundreds of billions in new EV and battery manufacturing.
We hear about new factory announcements all the time.
Dozens of gigafactories, battery component plants, assembly lines. They're currently under construction or just starting to come online across the country. The tariff wall is seen as a necessary defense mechanism.
To shield them while they ramp up.
Exactly. To ensure these massive investments and the tens of thousands of specialized jobs they represent aren't just crushed by foreign, state-backed, ultra-low-cost competition before they can even reach the competitive scale needed to drive down their own costs domestically. It's buying time for investment to mature.
Okay, this analysis leads us directly then to the strategic choices facing policymakers. If the tariffs are likely to persist, at least for a while, the U.S. absolutely must execute a flawless domestic catch-up plan.
Flawless is a high bar, but yes, execution is key.
Our sources lay out 3 core policy options going forward. Let's start with the one that seems most aligned with the current political and industrial consensus. Option A. What is Option A?
Option A is basically the fortify and catch-up strategy. The tagline is build here, sell here.
It can walls up.
Keep the tariffs high, maybe indefinitely, and aggressively double down on domestic production to try and close that BYD cost delta without ever letting the finished vehicles in.
Okay, double down. What specific actions does Option A actually require to succeed? I mean, closing a $10,000 or $15,000 cost gap seems monumental.
It requires immense strategic acceleration and a real push for vertical integration here. First, we absolutely need to rapidly scale up domestic battery and component manufacturing.
Not just assembling imported cells.
No, that's not enough. We need to focus heavily on the upstream stuff, the raw material processing. We need U.S.-made cathode materials, anode materials, separator production, not just final cell assembly. That's how you truly compress cost and hedge against getting hit by tariffs on the inputs later.
Makes sense?
Second, and this is the big one for consumers, the industry must deliver credible sub-$30,000 EVs at scale. And they need to do it now, especially with the federal credits gone. The urgency here feels almost existential for the domestic brands.
Sub 30K. That's the magic number everyone's talking about.
Yeah.
But that takes time to develop and scale. How do we bridge the immediate demand gap while the industry builds those cheaper EVs? People need cars now.
That's where the bridge technologies become absolutely critical under Option A. It necessitates using hybrids, HEVs, and plug-in hybrids, PHEVs, as a necessary pragmatic glide path.
So lean into hybrids for a while.
For the near term, yes. Their market share is rising rapidly anyway. The sources say maybe up to about 22% in early 2025, precisely because they offer consumers immediate fuel savings without the charging anxiety or the high upfront cost of EVs right now.
It keeps factories running and gives people options.
Exactly. Hybrids provide a pragmatic way for suppliers and manufacturers to retool their capital and labor gradually towards full electrification, while still giving consumers immediate improvements in total cost of ownership. But the ultimate non-negotiable goal of Option A remains clear.
Which is?
Achieving BYD-level costs, but manufactured entirely in North America, ideally within the next 3 to 5 years. It's a moonshot, but that's the target.
That is a staggering logistical and engineering challenge. Okay, what about Option B? That sounded like it tries to split the difference somehow.
Option B is the managed opening approach. Think of it as advocating for managed competition.
Managed competition.
Yeah, the strategy basically acknowledges that maybe the 100% tariff isn't sustainable politically or economically forever. Consumers might revolt or trade partners might retaliate eventually, but just opening the gates entirely is seen as far too risky for the domestic industry.
So let some cars in, but under strict rules.
Precisely. The approach is to admit some Chinese EVs, but under extremely strict quota-conditioned access rules. And critically, use the threat of granting or withholding that access as powerful leverage in negotiations.
How would the U.S. government, like the Trade Representative's Office, practically manage that? What kind of mechanisms would control who gets in and how many?
It would involve pretty stringent regulatory control. For example, they could mandate specific local content requirements, maybe only allowing models that are actually assembled in North America, even if by a Chinese company.
Using U.S. labor and some U.S. parts.
Right. Or maybe only allow models that can demonstrate fully audited, non-sensitive battery supply chains, proving they aren't using forced labor or stealing IP in their battery production.
That sounds hard to audit.
Very hard. The U.S. would also need to apply really stringent safety and cybersecurity rules, applying them equally to all imports, not just Chinese ones, to address potential IP theft or national security risk without looking like a blanket discriminatory ban.
And link it to reciprocity.
Most importantly, yes. Tie any tariff relief directly to verifiable market access reciprocity, basically saying, you want to sell your cars here, fine, but then U.S. companies need fair access to sell their cars and services in your market. Use access as a bargaining chip.
That seems incredibly complex to implement and enforce without a massive government apparatus.
It is, absolutely, which is why option B is often seen more as a potential medium-term aspiration rather than something that could be realistically stood up tomorrow.
What would the outcome be, ideally?
Ideally, option B would pass more consumer surplus, more savings to buyers compared to option A, while still attempting to discipline supply chain risks and security concerns. But yeah, it demands significant political consensus, really robust data auditing capabilities, and a huge enforcement bureaucracy, all of which are challenging to establish quickly and effectively.
Okay. And then finally, there's option C. This one sounded like the most radical departure, a real shift in industrial ambition.
Option C is the value stack pivot. This strategy is based on a potentially uncomfortable but pragmatic realization. Maybe, just maybe, matching BYD dollar for dollar on the commoditized hardware, the metal shell, the seats, the basic battery pack assembly, is either impossible for the U.S. or simply too costly to pursue globally in the long run.
So concede the cheap hardware.
Not entirely concede, but accept maybe a smaller, highly optimized auto manufacturing footprint, and instead focus on dominating the higher margin, higher value parts of the equation.
Which are?
The platform itself, the software, the data, the services, and crucially, the energy grid interaction.
So less focus on bending metal, more focus on the intelligence inside the car and the energy infrastructure that powers it.
Exactly. The core idea is to pivot labor, capital, and R&D away from trying to win a race to the bottom on assembly costs, and instead pour it into energy systems and electrification more broadly.
Like what kind of systems?
Doubling down on grid build-out, utility-scale battery storage, advanced heat pumps for homes and buildings, and especially crucial power electronics technology. And within the vehicle, win on the software-defined vehicles, SDV.
The brain of the car.
Right. Over-the-air services, advanced driver assistance systems, ADS, eventually full automation, fleet management tools. Basically, shift the profit pools decisively away from the physical metal and into recurring software and service revenue streams.
Let's slow down on power electronics for a second. You mentioned SiC and GaN earlier. Silicon carbide and gallium nitride. Why are those specific materials so critical to this option C pivot?
Okay, yeah. SiC and GaN are next-generation semiconductor materials. They're starting to replace traditional silicon in high-power applications, like in EVs.
Why replace silicon?
They're critical because they are dramatically more efficient at power conversion. Think about moving electricity from the battery to the wheels or from the charger into the battery. SiC and GaN waste much less energy as heat during those conversions compared to silicon.
What does that mean for the car?
It translates directly into tangible benefits. better vehicle range because less energy is wasted, potentially faster charging times because they can handle higher power without overheating, and smaller, lighter components like inverters and chargers, which saves weight and cost.
So controlling that technology is key.
Dominating the design and manufacturing of these advanced power electronics components is a high-margin, high-tech way to ensure U.S. technological leadership and capture value, even if we aren't necessarily building the absolute cheapest car shells globally. It's a critical piece of the value stack.
Okay, 3 distinct options. Fortify and catch up, managed opening, value stack pivot. Based on everything we're seeing, the current investment pipeline, the political reality, where are we actually heading right now? Which path is the U.S. on?
Well, given the massive investment commitments already locked in here in North America, those hundreds of billions aren't easily unwound.
Factories mid-construction.
Exactly. And given the political hardening of the tariff wall, the cross-party consensus on it, and the general risk aversion regarding that huge $1.2 trillion industrial complex, the most realistic near-term strategy seems to be option A, fortify and catch up.
Stick with the plan. Build it here.
That seems to be the default path for now. However, it will likely face increasing pressure to transition towards some kind of A-B hybrid in the medium term.
Why?
Because the pressure from consumers for more affordable options will inevitably mount, and the economic cost of maintaining 100% tariffs indefinitely might just become too high. The wall is buying time, but as we said, that time has to be used perfectly to deliver that credible sub-$30,000 EV built here, if not.
If not, the pressure for option B or even C grows.
Precisely.
That push toward the value stack pivot, option C, it is compelling because if hardware cost parity with China really does lag, or proves impossible to achieve quickly,
then the U.S. absolutely must focus on where the real profit pools are going to be in the 21st century car.
which you're saying is software and services.
That's where the high-margin, recurring revenue streams are increasingly being born. It's the software platform, it's ADAS and automation features people will subscribe to. It's this emerging idea of energy as a service linked to the car.
So U.S. firms need a mind shift.
They have to stop thinking purely like 20th century car makers selling a physical product and start thinking like mobility and energy platform companies. The underlying technology is advancing incredibly fast. The industrial philosophy, the business models, they have to catch up and shift the target.
And this transition you're describing ties directly into that grid advantage idea you highlighted earlier. EVs can't just be seen as transport anymore.
No, they have to be treated as national energy assets, integral parts of the grid.
How does that work?
Fundamentally, EVs must be treated as nodes in a national energy network. This requires a huge structural pivot in infrastructure spending and planning. We need much stronger public and depot charging backbones, obviously. But crucially, we need pervasive V2G and V2X integration.
Okay, define those for us again. V2G, V2X. Sounds like alphabet soup.
Right. V2G stands for vehicle to grid. V2X is vehicle to everything.
Meaning?
This is the really revolutionary shift. It's the ability for the car not just to take power from the grid when charging, but to potentially return power back to your house during an outage, that's V2H, vehicle to home, or even back to the utility grid, V2G, during times of peak demand.
So my car becomes like a backup generator or a grid battery?
Exactly. The car becomes a distributed energy storage resource. This capability can help balance the grid, reduce stress during peak demand hours, lower energy costs, and potentially even offer consumers a new revenue stream if utilities pay them for that grid service.
That sounds amazing, but also requires huge changes.
It does. This structural pivot requires shifting massive amounts of talent and capital into grid modernization, grid build-out, smarter software, and those advanced power electronics we talked about. These represent large, durable capital expenditure cycles.
That China can't easily replicate just by building another factory somewhere else.
That's the argument. Why is this deep integration of energy and mobility potentially harder for China to copy globally than just building a cheap car?
Why?
Because it's inherently dependent on local factors. While China can excel at building a standardized factory or even a battery plant anywhere in the world, coordinating millions of electric vehicles with a fragmented, localized power grid like the U.S. has.
Which varies state by state, utility by utility.
Exactly. It requires an extremely high degree of regulatory harmonization across states, deep cooperation with local utilities, customized data ecosystems that respect local privacy laws, standardized communication protocols. It's messy and localized.
Not easily centralized.
Right. This deep integration of energy systems and mobility depends intrinsically on local grids and local regulations, making it very difficult to centralize, standardize globally, or just export as a finished product. This is where the U.S. potentially could build an uncopyable systemic advantage if it plays its cards right.
Okay. Before we wrap up, let's go back to the consumer for a minute. Right now, today. The tariffs are high, the federal credits are gone. What are the actual near-term alternatives for people who want to participate in the EV transition or at least get better fuel economy at a decent value price point? What should they be looking at?
Yeah, the value landscape is definitely shifting. The sources point to maybe 4 key clusters of deals or options right now.
Okay, what's the first?
First, keep a close eye on the Korean brands Hyundai and Kia. They've been very aggressive with discounting and lease deals lately. They also tend to have strong charging partnerships and pretty good software packages, often making them arguably the best overall value proposition in that, say, $35,000 to $45,000 range right now.
Okay, Hyundai Kia. What's second?
Second, Detroit's mass market entries are still critical, even without the federal credit. Look for Chevrolet's lower-priced EVs like the Bolt EUV or the upcoming Equinox EV if they can hit their price targets. And check Ford's lease deals on things like the Mustang Mach-E. Manufacturers are often structuring those leases heavily to mimic some of the benefit of the expired federal credit, trying to soften that immediate price shock for the buyer, at least on a monthly payment basis.
So manufacturer incentives are replacing the federal ones. Somewhat. Makes sense. What about the third and fourth options? These sound maybe less like pure EVs.
Indeed. The third area, and it's the fastest rising segment in 2025, according to the data, is hybrids and PHEVs, standard hybrids and plug-in hybrids.
Back to hybrids.
For many consumers, yes. They offer a reliable, pragmatic glide path for improving total cost of ownership right now amidst the high EV prices or lingering charging uncertainty for some buyers. They are simply the sensible, lower-risk choice for many people who need reliable, efficient transportation now.
Okay. And the fourth?
Finally, don't overlook the used EV market. It's becoming increasingly compelling.
Why now?
Well, partly due to the rapid depreciation that EVs have seen over the last few years, plus you have dealers potentially looking to clear out inventory now that the new models don't have the federal credit making them as attractive. You can often find excellent economics on 2 to 3-year-old used EVs models that might have originally sold for $50, now going for $25K or $30.
With decent battery life left?
Often with strong battery warranties still intact. It can be a really strong entry point for value-conscious buyers willing to do a bit of homework.
Okay, good practical tips there. So this entire deep dive, it really has been a study in the high-stakes cost of industrial strategy, hasn't it?
Absolutely.
The tariff wall seems politically sustainable, maybe even necessary to protect the hundreds of billions already invested in trying to build Detroit's electric future.
But it's undeniably costly to the consumer right now, and it definitely slows down the pace of climate action compared to a scenario with open borders for EVs. The synthesis seems pretty clear from the sources, just opening up imports completely. Benefits consumers quickly, saves them money today, but it risks severely disrupting, maybe even destroying, large parts of the domestic industrial base, which is tied to trillions in economic output and millions of jobs.
So the smartest path isn't just hiding behind the wall forever.
No. The sources argue the smartest path is to use the time that the wall affords very strategically. Use it to truly own the next auto.
Which means?
It means delivering those low-cost local EVs. It means achieving high-margin software dominance. And it means building out that national energy infrastructure, the grid integration, the V2G that powers the whole ecosystem and creates that unique advantage. It's become an intense industrial race against time.
The sources really emphasize that the U.S. invented the mass market car a century ago, but now it has to completely reinvent it for this century.
And the rules are different this time.
Right. The next generation of mobility won't be won by horsepower or sheer steel volume or just relying on legacy brand loyalty. It looks like it will be won by mastering data, mastering those brutal cost curves we talked about, and executing a unified national strategy that finally integrates energy and mobility together.
The core question for policymakers isn't whether to compete anymore. It's whether the U.S. can actually build again quickly, affordably, and at the massive scale required. And that leads us right to the final provocative thought we want to leave you, the listener, with today. Tariffs buy time. They build walls, but they don't actually build the future themselves.
They create space but don't fill it.
Exactly. If the U.S. industrial complex, the automakers, the suppliers, the government support, cannot deliver a credible, scalable, sub-$30,000 EV built domestically within, say, the next 5 years, then this protectionist policy risks becoming just a graveyard for innovation. It could effectively seal American consumers off from global affordability gains for the foreseeable future.
A very high-stakes gamble.
It is. The final choice facing policymakers, and really the nation, is whether the U.S. will choose to primarily be the motor city of the 20th century, focused on protecting legacy manufacturing jobs at potentially high consumer costs, or if it can truly become the electric nation of the 21st century, leading with integrated technology, software, energy systems, and delivering mass market value once again.